Hello everybody, and welcome to my presentation on physiological responses of offensive and defensive play on amateur basketballers. This is in conjunction with CQUniversity as a part of my degree. Basketball is a very popular sport. It's played in a lot of countries around the world. In fact, it's played in 213 countries over the world with over 450 million participants worldwide. Early studies into basketball showed that it had a strong anaerobic component with a lot of going to and fro, but a lot of rest periods in between each of the components of basketball. Later studies showed it not only to be anaerobic, but aerobic in nature, due to the fact of the high speed that the game was played at and the durations that they were being played at. And they found as time's gone on, basketball's actually become faster and faster and has had less breaks and a lot more in-play time. Numerous studies have investigated the energy systems, and a few of the ways that they've used to measure these energy systems have been heart rate, blood lactate concentration, and RPE. These three areas are areas that we're going to also look at in our study. When it came to studying basketball, most of the research to date has been concentrated on total gameplay and position specific. When I'm talking position specific, I'm talking about things like guards, centers, forwards, things like that, not necessarily the elements of offense and defense. So let's start having a look at a little bit about the offensive and defensive elements of basketball. Little is known about the effects of offense and defense on the energy systems when it comes to basketball, and we've got to look at what this could affect and why we actually want to know this. One of the reasons could be to actually start monitoring the training loads of our athletes and make sure that we're not overtraining them. To make sure that game performance and fatigue isn't over the top. And make sure that we actually reduce the chances of any injuries through overuse or through not knowing exactly how much load we are placing through our athletes. So this brought up the research question that we came up with. We wanted to have a look at what is the effect of offensive and defensive play on the energy systems of our athletes. And is offense or defense more taxing on the body, or are they both very, very similar in their nature? So our study aims are going to encompass different parts of the offense and defense, and we're going to look at different ways that, different testing methods to see different components and see how they react to actually offensive and defensive play. So the first area we're going to look at is blood lactate concentration, looking for the anaerobic components of basketball. We're then going to have a look at heart rate and see how heart rate is affected by the offense and defense. We're going to look at fatigue through a line drill. So we're going to actually have people running up and down the court to see how fatigued they get after they actually perform the offense and defensive play. And we're going to have a look at perceived exertion. So we're going to actually ask people how hard they found the offensive components and the defensive components of play. Now we come to the methods section. Now we've got, as you can see here, 14 university students, 5 females, 9 males, with a spread of age, mass, height, and body fat percentages. Our measures that we're going to be looking at when it comes to all of our data will be their heart rate. We're going to use a polar heart rate monitor that's going to be affixed to their chest for this. And these measures were going to be done only during the time they're actually playing offense or defense. We're going to be performing a line drill before they start any of the competitive games, as well as one afterwards to actually measure the difference. For this, we're going to use some speed gates to make sure that the timing is very accurate. We're going to use the RPE, or rating of perceived exertion, with a 6 to 20 point scale, where we actually will ask each of the competitors or the people that are performing how hard they actually found each component of what we were doing. We're also going to have a look at the blood lactate concentration, and this is going to be done through an ear prick blood analysis, and we're going to have a look at different levels of blood lactate to see actually how hard they're actually using their anaerobic system. Now we're going to move on to how the actual day ran. So the day actually started with a bit of an information session to make sure that everybody understood exactly what they were going to actually participate in. We also made sure that everybody filled in their informed consent forms and made sure that they were filled in and signed. Personal particulars, including their age, their height, their weight, or mass, and skin folds were recorded. At this stage, we made sure that we also took the baseline capillary blood lactate levels. The next component of our testing was the first actual test, which was our line test. We're actually making sure that we can get a baseline to measure against a bit later. We then moved on to a 4 versus 4 half-court basketball game where everybody actually was assigned a role of either offense or defense. These roles were actually stuck to for the whole 10-minute period. During this time, people were subbed off after about 5 minutes to randomly get their blood lactate levels so that we could actually measure throughout the actual game where their blood lactate levels were. Following this, a second line drill was actually conducted to see what their fatigue levels would be. We also collected data about their RPE at this stage to make sure that we could keep all these things as they're actually thinking about them. Recovery time between tests was set at about 20 minutes, and then we actually started them again from around that stage 4 area, made sure that they actually conducted that line test again, and went all the way through, but except this time, instead of being their offense, offense became defense, and defense became offense. Now we're going to have a look at a few of the results that we actually found. Here we're looking at some of the interesting things that we're looking at anyway. The percentage of heart rate as a relative percentage of heart rate. What we're looking at here was that the actual difference between these two figures was actually classified as significant, set at a p-level of 0.05. So it showed that offense was actually significantly more higher than defense. As you can see, a lot of the other figures are actually fairly similar when we go along here, and RPE actually came out that defense was a little bit easier than offense. Further to this, we have a look at a bit of the line drill test data. The line drill actually showed up that offense had a little bit of fatigue set in is 0.88, so it's actually not that much difference in time, as you can see, and defense actually improved their times on their second line drill. We're having a look at this, and I'll explain a little bit later of why this might happen. Here we're actually having a look at a chart of the heart rates, the mean heart rates throughout the actual time period. As you can see, offense seems to have dipped just here, whereas the defense's heart rate actually stays up and actually seems to climb towards the end. So we'll chat about this a little bit later as well. So in this area of our discussion, we're going to have a look at why offense and defensive play actually seem to be slightly different. Now, it looked like at the end there, as you can see in our chart with the heart rates of the offense and defense averages, that the change towards the end of the game, where the defensive heart rates seem to stay higher and the offensive seem to drop off, we're having a look at that, and we're thinking that that might actually be due to stride length and variation in the way that they're actually having to move. Because in defense you have to move backwards and sideways more often than offense, and offense you're going forwards and you can pass the ball around a little bit more, and it seems that the energy consumption for an offensive player is going to be slightly lower than that of a defensive player. Blood lactate showed no real difference, so it still showed that we're actually looking at a sport that's very, very anaerobic in nature, but also has that aerobic components. RPE seemed to show no significant difference, and it once again just didn't come up with any complete changes that we could actually show in our paper. Though fatigue didn't show any statistical significance, the offensive players did actually record a slight increase in fatigue, so they performed 0.88% worse, whereas after defense they actually performed 1.38% better. Now, we're putting this down to the fact that we don't think everybody put 100% in until the end, and I think that was due to a little bit of lack of knowledge of how the testing was going to be completed, and that everybody always wants to improve on their last result. In conclusion, the peak heart rate seemed to be higher in offense, but the heart rate seemed to climb higher in defense throughout the actual workloads. There are no significant differences between the two, but we can see that at least improvements are there. Practical implications: offense and defensive seem to obtain similar demands, so that we don't actually have to concentrate on whether we're doing offensive and defensive drills to reduce fatigue levels. We can actually just do what the team is required.